Hey guys, so this morning we're going to move on in chapter 8. We're moving to lesson 2, which is 8.2, which is removing perfect square factors. So before we start, on page 279 of your book, you'll see at the very top it says the product rule for radicals. So if you remember last time we talked about the quotient rule. So we have the quotient rule. How about that pen? Outstanding. So we had the quotient rule. And the quotient rule said that if we had a radical that was a fraction, so let's just say 36 over, let's just do 16. We can actually split that up to where the numerator is a radical, and that's divided by the denominator that is a radical. And then we can go ahead and solve that. And we know that the square root of 36 is 6, and the square root of 16 is 4, and we can reduce that down to 3/2. Okay, that is the quotient rule, right? And that is written as n over a divided by b equals a over of b. Okay? So we can split that radical up into the numerator and the denominator. All right? So now we have a new rule which is called the product rule. And the product rule, since a product is the result of a multiplication problem, you think that the product rule would be associated with multiplication, and it is. So the product rule for radicals basically says that if you have the index of n and the radical of a times b, that I can split that up. And if you remember our example in our homework from yesterday, utilized this product rule. I was able to split up these different variables. So here I can split this up. The product rule says that I can take the radical of a, the root of a, and then multiply it by the root of b. All right, so for example, if I have the square root of, let's just say, let's say 32. All right. Well, the square root of 32 is also equal to the square root of 16 times 2. Right? A would be 16, B is 2. So then with the product rule, it says I can split those up. So that would equal the square root of 16 times the square root of 2, right? And the square root of 16 is 4. The square root of 2, we don't know. We can find out on a calculator, but since we don't have a calculator, we just leave that as the square root of 2. Therefore, that equals 4 times the square root of 2. So that's what this equals. And we are able to get that by utilizing the product rule to be able to split apart two numbers multiplied together. Okay, that is the product rule. So we can look at some different examples. We just looked at example 8.2a. All right. So let's go to let's look at example 8.2b, where we have the square root of 252. Well, do we know what the square root of 252 is? I don't. I have no idea. So we are going to factor 252 to find out what this equals. So to factor it, I don't know if do you guys remember doing prime factoring? You should. So all we do is we prime factor 252. So I have 252. I prime factor it by 2. That's 126. Factor that by 2, which is 63. Factor that. 2 doesn't go into 63 because that's odd, so 3. So that'd be 21. And 3 goes into that 7 times. 7 is a prime number. So those are all my factors, my prime factors of 252. So I can now write that as the square root of 2 times 2 times 3 times 3 times 7. Okay? Does that make sense? So then what I can do is, if I have 2 times 2, isn't that a square? Sure it is. So I can rewrite that as the square root of, what is 2 times 2? 4 times the square root of 3 times 3? That's 9 times the square root of 7, right? By using my product rule, I can separate those. 2 times 2 is 2 squared, which is 4. 3 times 3 is 3 squared, which is 9. And then 7 is just square root of 7. So then we can go ahead and get the square roots of each one of these. So the square root of 4 is 2 times the square root of 9 is 3 times square root of 7. Have no idea. Don't really care. So I'm just going to leave it as square root of 7. Right? Then I can go ahead and multiply. 2 times 3, 6. And I can also multiply it by square root of 7. So that becomes our answer. All right? So when you have a large number like this, you can prime factor it, starting with 2's until you can't divide by 2 anymore. Then you move to your next prime number, which is 3. And then you go to the next prime number until you exhaust all of your options. And you end up with a prime number. Okay? All right. Another example. Let's look at some with variables. Let's look at, let's look at this one. Let's look at example 8.2g. That would be the square root of 8 times x to the 4th times y to the 5th. Right? So if we prime factor that, we would have 2 times 2 times 2 times x squared times x squared, right, times y squared times y squared times y, right? And so with these variables, what you want to do is you want to divide those up into perfect squares, because that's what we're trying to find, is the square root of our factors. So what we can do here is, I've got 2 times 2, which is 2 squared, right, which would be square root of 4, times, I've got 1 left over, square root of 2, times, I've got 2 square roots of, or x squared, right? So I've got x squared times x squared times y squared times y squared times square root of y. So then what we do is we go through here and we find, what are all the perfect square roots? Well, we've got square root of 4 is 2 times square root of 2 times x times y times y times square root of y. All right, so if I multiply 2 times x times y, I get 2x squared y squared. And if I multiply square root of 2 by the square root of y, I get the square root of 2y, because I can use this to go backwards on my product rule. So this is your answer to this. All right, so we're going to do some practice of this. All right, and so what I want you guys to do is on page 281, so your homework, I want you guys to practice the product rule. So homework, this is really hard to see. Homework, page 281. We're going to do numbers. Let's do 13 through 24. All right, so practice on removing the perfect square factors, and that's basically what we're doing is we are prime factoring using the product rule to be able to simplify larger and more complicated radicals. Read the book. If you have any further questions, give me a shout on the message and I will do a specific video to help you out. All right, until then.